it's really, if you had to do it by hand, it's really heavy on writer's cramp. It's terrible. Anyway, I'll just talk you through it. Suppose there are two competing products, E and N, in the market. For example, this is the old problem, obviously. Explorer and Netscape. I actually remember when that was a thing. After 1 year, some customers will keep using the same product, but some will switch to the using the other product. You could actually also think of it as the the Monty Hall problem. Let's make a deal. Well, whatever. The idea is that you have a choice, and then you could either stay with your choice or switch to another choice. This evaluates the probabilities associated with that. And what you would actually do is flesh out what the probabilities would be in the long run, right? If you wanted to, but you could also figure out what they would be in the short term. All right. So after 1 year, some customers will keep using the same product, but some will switch. The proportion of customers that keep using the same product or switch to use the other product after 1 year is summarized in the following table. All right. So here's our initial state, right? Three-fifths of the population use product E, and 2/5 of the population use product N in the beginning. All right, that's what we're starting with. All right, 60%, 40%. We have this transformation matrix. I mean, whether it's defined as a stochastic matrix or not, it's still a transformation matrix. It's going to take a vector and change it from what it was into something else. All right, it's the definition of a transformation. All right, so what this is telling us is after a year, the E users, a quarter of them are going to stay, 3/4 of them are going to switch because the Explorer sucks. The N users after a year, 1/3 of them are going to stay, 2/3 of them are going to switch because Netscape sucked. But actually, it sucked more than Explorer, so that probably should be less. I'll take a typo on it. I've been meaning to update this for years. Edge and Chrome, right? Probably, or Firefox or something. I don't know. You can do Amazon or Google. Like if we wanted to just go with industries, Apple or Microsoft, Safari. Yeah, anything. I'll take it.
Anything where they're both trash, which is most things.
Yeah, they don't have to be trash because I could also play around with the ratios too. All right, so let me take you through the prob and stat way of doing this first. That's how we hook you in to learning the Markov chain. So, little tree diagram action. Three-fifths of the population use Explorer, 2/5 use Netscape. After 1 year, we would have the E people can stay with E or switch to N. The N people can stay with N or switch to E. Yeah, just following the table here, we would say we got 1/4 staying with E. So 1/4. We have 3/4 switching. So basically, everybody thinks the grass is greener on the other side, so they're all switching. They're like, what I have sucks. The other thing's got to be better. And then after the next year, they're gonna find out that the thing they had was just what the thing they switched to is just as bad. 1/3 is staying put. 2/3 is switching over. Now, in tree diagrams, probability. Get us in Calc 3 when we're dealing with the chain rule for partial derivatives. What do? You follow the branch, you multiply down the branch. Each different branch is a different possibility, so that becomes an either-or situation. Right? But what I'd want to do is figure out the different ways in which a person could end up in the E category, and different ways in which a person could end up in the N category, right? So the E users, we'd have 3/5 times 1/4 plus 2/5 times, I was about to write 1/3, I meant 2/3. All right, so that's what, 3/20 plus 4/15. Oh, math. Common denominator is 60, right? So 9, 25/60. Going down the N pathway, we'd have 3/5 times 3/4 plus 2/5 times 1/3. So 9/20 plus 2/15. So 27 plus, is it 35/60? I guess that makes sense. Should be the complement. We could reduce it. It doesn't really matter. Basically, what we're looking at is a market share. So you have 3/5 or 60% of the market being cornered by the E users or the company E, and then 40% by company N. Now, after 1 year, now 25/60, so almost, it's closer to a 50-50 relationship between the two companies, all right? So that would be a nonlinear algebra way of doing it that would just involve simple introductory problem stat, right? But let's take our matrix 1/4, 1/3, 3/4, 2/3, and create a vector, an initial state vector, 3/5, 2/5. I think it's going to be backwards from the way I did it there, but it's still going to get the job done, hopefully. Well, anyway, so let me just carry out the process. If I matrix multiply, matrix vector multiplication, I would have 3/20 plus 2/15. Is that right? Did I write it right? Something's iffy here. The products are out of whack.
I think it'll work if you do the transpose of the vector times. You're doing the.
So I put my vector on the wrong side. Because, oh, you're talking about it as a row?
Yeah, I mean, then
3/5 times 1/4. My associations seem to be screwy here.
Just swap column two.
Swap column 2 with
And just swap
swap row 1 and row 2, and it'll work. But then that'll give us the same stuff. Right, just in a different order.
I guess you have to create like a keep and switch column instead of like a explore and landscape.
Oh.
Right.
Unless I did my products wrong.
Keep both.
Something. I think it might be my my what you call it probabilities. The way I did the tree diagram. What's 3/20ths plus 2/15ths? Does it end up being 5/12ths?
So you're trying to get numbers that are more similar to what we just did?
Yeah, the whole point was to get actually the same answers as what I got here.
I think because what we did before was finding out who was with E and who was with N. Now what you're doing is you're using keep and switch instead. So 2/3 and 1/3 would have to switch.
Oh, okay. So I made my matrix. Oh, I made my matrix wrong. All right. So. All right.
I mean, it would be right if what we did before was finding out.
Keep and switch. Yeah. Oh, I guess I could do that. Instead of manipulating the matrix. A little bit more erasing, but I feel like it would require less thinking. So keep. I suppose it would probably help if I actually asked a question related to the distribution, like what kind of distribution am I looking for? Okay, yeah. So the keeps. Three-fifths times 1/4 plus 2/5 times 1/3, which you can see would give us that. So there we go. It's like spoiling the punchline to a joke. Sucks. It's supposed to be this big reveal. Everybody gets excited. We learned something awesome. 9 plus 4, 13 60s? Is that right? 17 60s. Oh, it is 8. And then the switch would be 3/5, 3/4 plus 2/5 times 2/3, So that in theory should give us everything else, right? 9/20ths plus 4/15ths. Just check anyway. 27 plus 8/30. 27 plus 16 would give us 43. 43 16ths. Anyway, so I mean, so as we just found out, or I found out the hard way, we could have some vagaries when it comes to like what the question is actually asking. So if it's asking for the distribution of keeping and switching over time, which I guess, I mean, there might be some value in that, where it's like if you want to know what the likelihood is that you're going to actually hang on to whatever consumers you have, right, okay. But if you're looking for kind of like measures in the moment, like after 1 year, after 2 years, after 10 years, after 100 years, what the percentage of the market will be yours, then we would have to rearrange the matrix. Okay, so,
Just the transpose of the
yeah. So it wouldn't be too crazy, but since I was kind of vague, well, I was very vague in the framework of the question, I've lost track of what I was even asking. Anyway, if you were to do this after 2 years, the way you would handle it would be, instead of actually creating a tree diagram with more branches, take your new matrix or your new vector and multiply it by the result. Well, that is the result. Multiply it by the A. So on the next page, there is a program that you can put in your calculator, because the next part after that would be, what is the distribution if the market is said to be stable? So that's stating, you know, like if you were to continue this on and on and on, what would be the distribution of keeping and switching at the end of time, for example. So obviously you don't want to be doing matrix multiplication until the end of days, right? So the way you would handle it would be, I think personally, it would be to use that program. Actually, this is probably as good a time as any to type that in. So let me show you how to do it, and then we'll come back and finish this problem. I guess maybe it's 2 pages away. It's a very simple program. I wrote it myself, so it has to be simple. There's some little details in there that, it's like, do you necessarily know to do that on your own? Probably not. But then there's some other things that I think are pretty obvious, right? Like you're actually multiplying matrix A by matrix B. So that should be, like there's some matrix multiplication in there, so hopefully that would make sense. Anyway, you're going to hit Program, select New, Create New, and title it something related to the topic. Markov sounds like a wonderful possibility. So alphanumeric keys. And so this is typing in a string of values is kind of a pain, but doable. So MARKOV. All right. Whenever you create a label within a program, you're creating an anchor within the program, so somewhere where you can go at any moment. So when I select go to A, that's going to bring me to this anchor and create that iteration process. So almost everything you need is in the program menu. So hit Program, and you can see, instead of it bringing you to, because we're now in the program editor function, instead of it bringing you to New, Edit, and so on, it actually brings you to all the commands that you would find necessary to create a program. So you're just looking for the one that says label, all right? So now just to kind of familiarize yourself with this, you might want to scroll through it. But the control menu is not really, I mean, there's some things in there. The input-output is what you, well, the output I think is obvious, but the input is how you would ask a person to actually put in information. It's overly complicated to put in a matrix as part of a program, so we just put the matrix in before we run the program. But here we want label. So in the control menu, option 9, label. For A, we select alpha math. Now I want to multiply matrix A by matrix B. So we get A and B the same way we would get it if we were doing the, the matrix operations. So second matrix name of A, second matrix name of B. So that'll be the matrix multiplication. So if I put in my stochastic matrix, the probability matrix, and for A, and then for B I put in my initial state vector, A will multiply against B and give us the new vector after one unit of time, one iteration. I'm going to store that into a new matrix C. So second matrix C. All right, so this is all happening behind the scenes. If you ran the program as is, it would compute the product of A and B, store it into C, but then not tell you anything. I suppose you can go into matrix A, B, and C and get what you need, but it would be nice if it actually displayed that information for you. So program, it's an output measure, so display output option 3. Display C, store, oh, sorry, not store. I'm used to my sideways arrows being store. You want to convert it into fraction form, I think, where possible. So math bracket, so don't hit store. So delete that. Math, enter, enter. I always like to, after it does an iteration, because I have a program for Newton's method, I have other iterative processes that I created. I always like to have it pause so I can stop, take a look, take note of what's going on, and then continue on with the process. So from there, I would go back into program, select pause. That's not an input output. Scroll down to option 8 in the control menu. Now I want a conditional, right? I want the calculator to determine, and this is where we're going to, I mean, I'm stealing my own thunder a little bit, but we're going to determine if something is a steady state vector, okay? Which, what that means is that there's no difference in the initial state vector and the subsequent vector after an operation, okay? So that's kind of an important thing to think about going into what we're going to talk about next class, eigenvalues. Right? So if there is an inequality between the initial state vector B and what the product is, then I want the calculator to do the whole thing over again. All right? So program, option 1, control menu, option 1, if C is not the same, so not the same as in your second math menu, that's the test menu. That's how you can test conditions. You have all your inequalities. Option 2 is the one I want. If C is not the same as B, then, so new line for then, this is where the iterations happen. Then I want the calculator to take what it got for C, dump it back into B, and repeat the process. Right? So C goes to B. and then repeat the process, go to A. Alpha math for the A. There's no save button on this, so once you're done writing the program, once you get down to the go to A, just quit out of there. And you have your program. Because, just going back to that problem, the next step in the process would be if I didn't have that program. I mean, even doing it by hand is it's still a pain, because if I have to find, if the question said what's the distribution after 20 years, and it will, because I tend to kind of be a jerk like that. If I show you how to write a program, you could damn well bet I'm going to ask you to use it at some point in a way that penalizes people that don't have the program. All right, so I would put in, so I have my my probability matrix as A. Now I'm going to do it without the program first. Put in the 3/5. I hear the scurrying associated with people now starting to type in a program that they should have been typing in earlier. So A times B, if I were doing this out, get that, math, enter, get my answer, right? So then if I were doing this without the program, I would then have to get this in to matrix B and do it again. So either by typing it in, or, you know, if you're savvy enough, you can store it in as matrix B. But then you have to go up, so hit second enter a few times, whatever. Repeat the process, math bracket, and then you would get that. So you can get it. You know, for this problem, it's not a big deal. Distribution after 2 years. Right? Because the distribution is really just going to be this guy, because we're assuming the same probabilities are in play, and that's, you know, that's an assumption that we have to make with Markov chains, or regular Markov chains. All right, so what this is giving us is the proportion of keepers and switchers after 2 years. And you could see that the percentage is getting lower and lower. Right? So here it was pretty small, or smaller anyway. Now it's very small at that end. It's a very drastic difference between the one end and the other end, right? But when I say if I'm going to create a stable market, you know, like I would want to know in the long run, what is the proportion of keepers and switchers? Okay, so this is what you'd have to do if I wasn't so nice. Sometimes I like to point out how nice I am. You would have to take this answer, dump it into B, do the multiplication again. Get an answer, take that, dump it into B, do the multiplication again, get an answer. Keep going until you get 2 consecutive iterations that give the same vector. All right, so if I do this again and I get the same exact answer, I got lucky. All it took was 2 iterations for me to get where I needed to go. But it's possible it might take 13 iterations or 100. right? So on a test, what I ask you to do, just to like if you're using the program, you're in luck that you get to use the program. But the one little caveat is I need you to also tell me how many iterations it took for you to get to the steady state vector. The steady state vector is the vector that it levels off at. Just think of it as a limit. What is the limit of the vector as the number of iterations approaches infinity? Right? So how do we use the program? Start off. It's actually very easy. You have to actually put the information in first. 3/5 and 2/5, right? All right, my A matrix doesn't change unless you change it. Program, Markov, enter, first iteration, second iteration. Okay, so obviously I screwed something up. Oh, you know what? I think it just blinked out. Whoop. Third iteration, fourth, fifth, sixth, seventh, eighth, ninth.
Can you go back to the program?
Not yet. Keep going until you get no change. The program's in your handout. I can go back in a second, but let me just finish doing this. You keep going until there's no change in consecutive iterations of your program. It's much quicker on yours, because this one, for some reason, has a lag. And then once there's no change, well, it should say done after the first repeat, but it's going with approximate values. So if the calculator is not 100% convinced, then it won't stop. But you could actually just count and say, once you get to the first instance of the repeated vector, that's the last iteration, right? So you have 4/13, 9/13 on the keep and switch. So what this is saying is, in this industry, in the long run, you're looking at 4/13 of the population keeping and being satisfied with what they have, 9/13 switching. Right? I can think off the top of my head of a particular situation right now in the real world where that is definitely happening. No? Can you? No? iPhone, yeah. I mean, I've kept my iPhone though. I think something more around the house. I don't know. It depends on where you live. So every March, somebody comes knocking on my door, and every October, somebody from another company comes knocking on my door. Nah. But you're thinking along the right lines. Nah. Cable. Yeah. March is Optimum. Cable. Verizon is in October. It's like clockwork every year. And then like clockwork, I switch almost every time because they offer a better deal, so I switch. All right. So obviously, I'd be consistently in the switch category. I'd be one of the 9/13s that pretty much always does. But there's plenty of folks, I guess, that hang on just for the comfort. I mean, there are people that they pay whatever it costs just because they know that channel 60 is SNY on Optimum. Like, I don't care. Now the remotes have voice control. I have no idea what any channel is. I just ask for what I want. I'm like, I want to watch Teen Titans. Puts on Teen Titans. So, 600's Netflix on Optimum, if anybody wanted to know that. So,
I didn't know there was a Netflix channel.
there is, yeah, on the new Optimum. There's a YouTube channel too.
Really?
Yeah.
I never knew that.
I don't know what it is.
Plug it in my laptop with like this.
Hey, just watch it on a big screen now. You can watch TCAN 290 on your big screen at home. So,
Another account to chunk.
Well.
Oh,